All right, so we see that the variable is up here, and to reach it, we have to stand on a log. And this is an environmentally friendly question because it has an E base, natural base, and so we do what to both sides? ln. And then with the exponent up there and a log as part of the expression, I can do what with that exponent? Put it in front. Good. And then what is the exponent of e that gives us e? 1. And so we have x squared equals ln of 200. Now, if x squared equals 16, what does x equal?
4.
That's good for B students. Plus or minus 4 is good for A students. So x equals plus or minus ln of 200. And that's in calculator-ready form. Plus or minus the square root of ln of 200. So x is approximately plus or minus, go ahead. 3018. Is that 17 and a high number or 18 and a low number? Okay, looks good. So here is the calculator-ready form, and here is the decimal approximation. So what you could do for the upcoming quiz and test is, since part of it will be calculator and part will be no calculator, my recommendation would be, while you're working on the no calculator section and you get to this question, do up to here. And then all you have left when you turn in the no calculator section is one step, the calculator section, not the whole problem. Might be a better way to use your time. We had another suggestion here that this is an exponential form. Why can't I rewrite this in log form? The exponent of e that gives you what? 200 is, and who is the exponent? X squared. Well, log base e has what shorthand? ln. And so we can jump to this step if we see that this question can be written using the definition of a logarithm. So either way is fine. Either log both sides or use the definition in this case. First of all, do something with the fact that there's a dot here. And then we'll talk about the next step in a moment. All right, so when we multiply two numbers with the same base, we do what with the exponents? Add them. And I'll get negative 2x plus 1. Okay? Now the second idea is x is the variable I'm solving for. I know, e looks like a variable. E is actually confusing here. Treat it as a number, like a 3 or a 2 or whatever you want to call it visually. So then, for solving for x, and where is x? Way up there. I can ln both sides. And so I have ln of e. And where does the negative 2x plus 1 go? In front. And I can ln the right side also. Then, what is the exponent of e that gives us e? 1, right? So that's not really there. And then to get to this x by itself, what two things do I do? How do I get rid of this 1? Subtract 1. And how do I get rid of this negative 2? Divide by negative 2. because it's attached to the x by multiplication. And now it's in calculator ready form. Can someone push a few buttons for us?
To double check it. This isn't
Okay, now, or, again, for those of you that see this as an exponential, the exponent of e that gives you 3e is negative 2x plus 1, and you'll see that essentially you get the same step here as you do here. So either log both sides or use the definition of a logarithm. Okay, so to do this in the calculator, what I would do is alpha and f1, which is the y equals, enter, and I'll make a fraction. Then I'll do ln 3, and e is above the division in blue. So blue key and division. Close parentheses, then subtract 1, then go down for over, and then negative 2, enter, and looks like whoever gave me that answer was correct.
It's negative. Yeah.
Except that, oh yeah, there's a negative here. Very good. Good catch. So, what did you try? You did what to both sides? You log both sides, okay?
I thought you couldn't log negative there.
Well, okay, again, here's the idea. First of all, we see that the variable is in the exponent position. Second of all, we see that we can't make the bases the same like we did in the previous unit, right? Because that would make it a lot easier. Make the bases the same. If things are equal, they're equal, and we're done. Okay? So we want to get to this variable. So we log both sides, and where does that variable go? Down. And so in terms of what we've been doing, this looks promising. But then, yes, you're right. We have an issue here. We have an issue here. We have an issue here. What is the base here? 10. Let me read this to you. The exponent of 10 that gives you negative, I don't care. When will that happen? Never. If the base is positive, and you raise it to any exponent, positive exponent, negative exponent, fractional exponent, any exponent, the result is going to be positive. And so we talked about this position never being negative. You're right. It is never negative. Therefore, I can't do this. Therefore, there is no solution. Okay, I'm going to do this with you in steps. Step 1, I need you to see the multiplication here, and then use an Algebra 1 idea. Do that and then wait. All right, so the 500 is attached by multiplication. To start to isolate things, I should do what? Divide by 500. And so the left-hand side is 1.05 raised to the x over 4. And the right-hand side is 2 over 5, also known as 0.4. Is the variable is way up here, and Mr. Mori can't reach it. So do the next step. So since Mr. Mori couldn't reach it, he had to stand on a log. And since he doesn't care about the environment, he just stood on a common log. Okay, then the next step is to deal with this somehow, because I now am talking about logs. You do that. So, what did we do with the x over 4?
X over 4 is log.
Where do we put it? In front. Good. Power property of logs. Now there's a couple of things we can do after this. Let me lead you to one of them. If you'd rather not do the one I'm suggesting, do the one you want to do. But I would suggest, first of all, getting rid of this 4 somehow. You and your partner come up with a plan to get rid of that 4. Okay, so then how do I get rid of that 4? Multiply both sides by 4. Now, do I have to distribute this 4 to anybody? Do I do the 4 here and here and here and here? No. It's all multiplication, right. So then, what's 4 over 4? 1. And so we have this left. And we have this left on the right side. So far, no touching the calculator. Next, what I want you to do is to consider the dot here and come up with the next step. Okay, so how do I deal with that dot there?
Well, you divide log 1.05.
Good. Divide both sides by a log of 1.05. And so even though you have yet to turn in the no calculator portion of the test, you've gotten this far. You can write this down in calculator-ready form, and all you have left to do then is the right-hand side. So go ahead and do the right-hand side and see what you come up with approximately. So this is approximately 75 point.
121.
1, 2,
Negative 75.
2 what?
It's negative 75.
Oh, negative, I'm sorry, negative 75, 1, 2,
1.
1. Okay, so calculator ready. Approximate to 3 decimal places depending on the directions. Good job.